We're going to look at factoring a 4-digit number quickly. Now, how you approach this depends on what tools you have. If you have a calculator, you can simply divide by a bunch of small integers like 2, 3, 4, 5, etc. You only need to go so far. You could look up the square root of this number, and you only have to test up to that. But we're going to minimize using a calculator. There are some divisibility rules, and I have links to those in the description. They're mathisfun.com/divisibility rules. And a calculator I use is a Desmos scientific calculator, but feel free to use any 4-function or scientific calculator. All right, we're going to factor this. We need to figure out one number this is divisible by. There should be a few obvious numbers. One of them is 10 because it ends in a 0. So I could go with 10 times 182. That would be one option. Another that I saw immediately is this was even, and so I could have just divided by 2. And the other number, now if you're not sure, you'll need to do some long division or use a calculator. So I have the Desmos calculator here, so I already did that computation. You can of course do long division to get that number. All right, here's some divisibility rules. You probably knew the rule for 2, if the last digit is even, divisible by 2. 3, sum of the digits divisible by 3. Now some of these get a little more complicated, and I'm not going to go through all of them here. 5, last digit is 0 or 5. So these are good to know. So let's go ahead and keep factoring. Now, neither 10 nor 182 are prime, so 10 is 2 times 5. Now 182, this is even, so we can get a 2 out of there. And now if you don't know what this is, you're going to have to divide by 2 using long division. But we just did it. So instead of 910, it's 91. All right, so from here, 2 is prime. What about 91? So 91's a bit tricky. So let's go back through these rules here. It's odd, so it's not going to be any of the evens right here. It's 91. Sum of digits divisible by 3. 9 plus 1 is 10. So that's not divisible by 3. It's not divisible by 5 because it doesn't end in 0 or 5. 7. We got a shot at 7. If it's not divisible by 3, it won't be divisible by 9. So let's go ahead and try maybe a 7. So 1 times 7 is 7. Subtract 21. 7 goes into 21 3 times. All right, 7 is prime, 13 is prime, so we're done right here. We can write 1820 equals, I like to put the small ones first. There's 2 2's, so we can write it as 2 times 2 times, next smallest is 5, 7 times 13. Sometimes it's better to write repeated factors with an exponent. So there's the prime factorization. So again, if you have a calculator, what I could have done is just gone through and did 1820 divided by maybe you thought 4, so you get 455, so you can test it out here. Now the square root, 1820 square root, oops. You won't need to go past the number 42. However, if you built your factor tree, when you get down to primes, you're done. So you don't need to test any other numbers as long as you factored it all the way down to primes here.